Greetings, mathematicians. Today our warm-up is a dot talk. Calculate how many dots do you see and how do you see them? Again, using your hand signals to show how many different ways you see them. Be sure that you're thinking about mathematical vocabulary to describe your thinking. Words like horizontal, vertical, diagonal, groups, things like that to describe. Teachers pause while students work. If you're in class, teachers, you can pause here and record what your students saw, both with colors and writing down the equations as well. So we have some new vocabulary that we're going to talk about today. The first word is compose, okay? You might have heard this word in music class, like a composer composes music. In math, it's similar. When we compose, we put things together. Just like in music, a composer puts notes together to make a song. In math, when we compose numbers, we take individual numbers and put them together. We can also decompose in math. Again, when we put the prefix D in front, it means the opposite. So we're going to break apart if we decompose. So again, we've been doing a lot of that using our break apart models or our math mountains. We could break apart or decompose 8 into 5 and 3. We could decompose it into 4 and 4. We could decompose it into 2 and 6. So we can choose how we want to decompose numbers, and the way we decompose them helps us use them in calculations more easily. Our learning target for today is I can identify and apply the commutative, associative, and distributive properties. So we're adding in a new property today, the distributive property. So go ahead and rate yourself. Where are you on the learning target? Are you at a 1 or are you at a 5? Go ahead and show your teacher where you are. So today we're going to continue on with properties of numbers. Remember, in math, properties are rules that work for all numbers. And we've talked about there are addition and multiplication properties. Our first property is our commutative property. So if we look up here at this first red square, I'm going to have teachers pause, and students, you're going to talk to your partner or your elbow partner about what was the commutative property and what did commute mean. Teachers pause while students share. Remember the commutative property? We thought of the word commute. Remember, Dad can commute back and forth from work, or we go commute back and forth from school. We have a property for addition and multiplication. And remember, that's the property, that flip-flop property, where we can just change the order of the numbers. It's the same distance to school as it is home. Now, the other partner on the other side, you're going to explain what was the identity property again. Remember, think about what does the word identity mean and what is the identity property. Teachers pause and students share. So, the identity, remember, your identity is who you are. The fingerprints revealed the thief's identity. So we have two properties of identity properties. One of addition, when we add 0, it's going to stay the same identity, say 3. And in multiplication, the multiplicative identity property tells us when we multiply by 1, our product is going to stay the same. Okay? Our next property is the associative property. So again, we think about what does the word associate mean? What did we do in class when we were talking about the associative property? Teachers pause and students with your elbow partner discuss what was the associative property. Again, if we think about the word associate, remember that's who we kind of hang out with. We can associate with people at school and at home. So associative property. We also know that if you have like a law firm or a doctor firm, sometimes they'll say so-and-so and associates, because all those people work together. So our associative property, again, we have both an addition and a multiplication. The thing that's the same about both of them, the addition, remember, we're always talking about our grouping symbols. We're just changing the grouping symbols to make the problem easier to work with. So our parentheses are changing. In the multiplication example, again, we're doing 5 times 4 first in this one. And then in the next example, we're just changing our grouping symbols, but the order of the numbers stays the same. Today we're going to add our final property that we're going to talk about this year. It's the distributive property, and we're going to talk about what that means in just a couple minutes. Okay? So with your elbow partner, look at this equation. What is changing and what is staying the same. Remember, mathematicians always look at the patterns that they see. What's changing and what's staying the same, and that will help you determine which property we are talking about. Okay, so go ahead and talk to your partner about which property it is and be ready to explain it if your teacher calls on you. So in this example, I can see that my numbers are all staying the same order, 3 plus 7 plus 9. On the other side, 3 plus 7 plus 9. I see that my parentheses or my grouping is what is changing. When I change my grouping, then I am talking about the associative property. So I can narrow it down to these two examples. They're both associative, but now I have to look at my operators. Well, in this one, I'm adding, so I have to have the associative property of addition. So this would be my answer. Let's look at this one. Again, look at what is changing first and what's staying the same, and then which property are we talking about. With your partner, come up with your answer. If we look on this one, I see that the order of my numbers is changing. I'm flip-flopping my numbers. When I flip-flop, remember that's going to be my commutative. I commute back and forth to work. It doesn't matter the order. Commutative property. And my operator is addition, so it's got to be the commutative property of addition. So the very last one on the bottom. So today we're going to talk about our final property, the distributive property. So I want you to think about, again, what does the word distribute mean? If someone distributes something. Teachers pause and students share with their partner. When we distribute something, we break it apart or we share it. Okay? So we think about what that means. I could distribute money to my family. So Mrs. Carlson will distribute the money from the sales to her family. I might distribute the papers to each of you or hand them out so that you each get one. But when you distribute, you break something apart or you share it. So in math, the distributive property only works for multiplication. So this one, there is no addition example as well. It only works for multiplication. And the distributive property allows us to decompose numbers into friendlier chunks to multiply and then combine the products. So this is a property we use all the time to make doing mental math easier. So let's look at an example down here. If I have 6 times 7, or 6 groups of 7, if I don't know my 7s, I could think about decomposing my 7s into maybe a 5 and a 2. Because I do know my 5s, counting by 5s we've all agreed was really easy, and doubling things is really easy. So I could look at my problem over here, 7 groups of 6. But if I look at that, 7 and 6 are usually factors that people struggle with. But I'm going to decompose my 7, so I'm still going to have 6 groups, but now I'm going to have 6 groups of 5 first. And then I'm still going to do my 6 groups, but I'm going to have 6 groups of 2. So I'm taking my 6 and I'm distributing it to both the 5 and the 2 since I broke them apart or decomposed them. So when I look at that, I still get the same product because if I did this part, 6 times 5 would be 30, and 6 times 2 doubled is 12. So then what I would just do is take the 30 and the 12 and put them together, and add them back together, because remember up here we broke them or decomposed them, so once we find the product of each part we have to put them back together to get our total of 30 plus 12, which would be 42. So again, it's an easier way maybe to figure out a product of a number I didn't know the factors. Okay, so let's look at another example. For our distributive property of multiplication, again, now I'm going to say 3 groups of 14. Well, I have a 3 song, but I don't know it all the way up to 14. I don't have a 14 song, so I'm going to break down my 14 into parts that I do know. I could decompose it into 10 and 4. If I did that, I could think about, first I'm going to go 3 groups of 10. So I'm going to distribute this 3 to the 10 first, and then I'm going to distribute it to the 4. So 3 groups of 10, if I picture that in my head, I'm going to have this picture, which would be 30 items. 3 groups of 4, which is going to be 4, 8, 12. And now, since I decomposed it first, I have to compose it again. I have to put it back together. 30 plus 12 is going to get me 42. I could have also done 14 plus 14 plus 14, but this, I know those facts quicker, and for me that was easier. So discuss with your table partner what makes more sense now about the distributive. We're going to keep talking about it, but what are you noticing about the distributive property from the 2 examples that we did? So here's another example. If we wanted to use the distributive property and decompose 7 into 2 easier numbers, I want you to think in your head, what 2 numbers would you decompose 7 into to make this an easier problem to do? Maybe you chose 5 and 2. To me, 5 is always easy because I can count by 5s and 2's doubling. So I could either do 8 times 7 like this and sing my 7 song or my 8 song, or I could break it apart or decompose it. I could take the 8 and multiply it by the 5 first. 8 times 5, so if I picture that in my head, 8 groups with 5 in each group is going to give me 40. And then distribute the 8 to the 2. 8 times 2 is 16. So 8 times 2 is 16. So now I have 40 and 16, but because I broke them apart first, now I need to compose them or push them back together to get my total. So now 40 plus 16, 40 plus 10 more would be 50, plus 6 more would be 56. Okay, so let's look at this one. Now we're going to distribute. I've already told us that we're going to have our 4, and we're going to distribute it to the 8 and to the 6 inside the parentheses. So I want you on your whiteboard to write this down, and I want you to figure out each part of each product for this distributive problem. Students at home, write this on your paper. Teachers pause while students in class solve it, and then have them hold up their answers and talk about them. Okay, so my first step, I have to take my 4 and multiply it by my 8, or distribute it to the 8. So 4 groups of 8. If I figured that out, I could sing my 8 song, 8, 16, 24, 32. It's going to be 32. And now I need to distribute the 4 to my 6. 4 groups of 6. I could sing my 4 song or my 6 song, 6, 12, 18, 24. And I would get 24. And then the last step is I need to combine or add them back together to get my total answer. I'm going to do my 10s first. 30 and 20 is 50, plus 4 and 2 is 6. So my total answer would be 56. Let's try a different one. Now we're going to distribute 4 times 7 and 4 times 7. So go ahead, write this on your paper or on your whiteboard and solve it, and then be ready to explain what you did, and don't forget to do that last step of calculating your final answer. So my first job is 4 times 7. If I did that, 4 times 7, I could go 7, 14, 21, 28. And another 4 times 7. So breaking it apart this way is nice because I only have to figure out one product. Still going to be 28 over here. And then to find my total answer, I'm going to combine 28 plus 28 or double it for my final answer. So if I do 28 plus 28, 8 and 8 is 16, or 56. My final answer is 56. Another way I could decompose this problem is I could do 4 times 10 plus 4 in parentheses. So write down your problem and then solve it on your paper or on your whiteboard. So if I started out 4 times 10, I'm going to distribute my 4 to my 10. I'm going to get 40. And then I'm going to distribute my 4 to the 4. And 4 times 4, I know, is 16. And then my final step would be to take the 2 parts I decomposed. I got to put them back together. 40 plus 16 would be 56. 6. With your partner, discuss what do you notice about the distributive property after seeing 3 different examples. Remember those questions that we're always asking ourselves are what's the same and what was different about the distributive property than some of the other properties we've talked about. Teachers pause. So let's look at this problem. 4 times 14. We just did that problem multiple different ways. I'm going to show you all the different strategies we used to decompose the number. And I want you to look and see which one do you think was easiest for you to solve mentally. If I wouldn't let you use paper or a whiteboard and you had to try to solve this problem mentally, which way would you want to decompose 4 times 14 to make it an easier problem? Would you want to use way A, break it down into 10 plus 4? Would you use strategy B, where you'd break it into 7 and 7? Or would you use strategy C, where you'd break it down to 8 and 6? I want you to write your answer on your whiteboard, and then I want you to think about how would you explain it. And we're going to call on a couple people to share which strategy works best for them if they had to do this mentally. Okay, so there isn't one right answer. Again, it's which one works best for you. I would probably choose A for myself because I like multiplying things by 10. That's easy. 4 times 10, that's a super easy problem. I can get 40, and I know that right away. And then I can do 4 times 4, and I know that's 16. And then it's easy for me to add a number with a 0 in the ones place, 40 plus 16 to get 56. But if you know your sevens well, breaking it down into 2 sevens might not be too hard either, because if you know 4 times 7, you only need to do one fact, which would be 28, and then you're just going to double your 28 again to get to 56. I think way C would be the most difficult for me because I have to do 2 kind of harder problems, 4 times 8 and 4 times 6, and then add them together. So either A would probably be my first choice, but if you know your sevens really well and you wanted to break it down into 2 sevens, that could also work. Again, if the idea is that we want to break it down and to make it to numbers that are easier to work with, then anytime we can make it into a number that ends in a 0, like a 10, or a number we know our factor is a 5, or a 10, or a 2. Remember, those are our benchmark numbers that make it easier to do mental math. So remember the distributive property. We could write it like this. So if we have 3 times, and then we have parentheses, 2 plus 4, instead of adding the numbers first and then multiplying, I could distribute my 3. So I'm going to take my 3 here, and I'm going to distribute it to my 2. So now I'm going to have 3 times 2, and then I'm going to have 3 groups of 4. So I'm going to break it apart first or decompose it, and then I'm going to find my product of each part. So instead of doing 2 plus 4 first and getting 6, and then having 3 groups of that, I could think of it as I could decompose or I could distribute, and I could say 3 times 2, 3 groups of 2 would be 2, 4, 6. 3 groups of 4 would be 12. And then again, if I wanted to find my answer, I would add those 2 together to get 18. So the distributive property says multiplying a number by the sum of 2 numbers, remember the sum means when we're adding those 2 numbers, is the same as doing each multiplication separately. Okay, so I could have done it this way first. I could have added 2 and 4 and gotten 6, and then 3 times 6 and gotten 18. Or I could use the distributive property because it's going to be the same or equivalent if I distribute my 3 and break it into 2 parts and then combine the parts again at the end. Okay, so let's practice using the distributive property some more so that we can get good at it. This is how we really use it, is when we're trying to decompose numbers to do mental math on large numbers. So on your whiteboards, think about this problem, 5 times 61. If I asked you to solve this problem, we don't know a 61 song, and we don't know our 5s all the way up to 61. So if we think about, because of the distributive property, I know that I can decompose my 61 into parts to make it easier. Which 2 parts would you decompose your 61 into to make this an easier problem? Write it down on your board. Teachers pause, and then have students share why they chose their numbers. If it was me, I would break it down into 60 and 1. Because look, I like numbers that end in 0. I like multiples of 10. They're a lot easier to multiply. Okay, so now I would have 60 plus 1, but now I need to distribute. Remember, I broke it apart so it's easier to multiply, but now I have to multiply it by each number inside. So I would take my 5 times 60 and my 5 times 1. If I calculate that out, 5 groups of 60, remember this is like 6 tens, 5 groups of 6, I know is 30, so 5 groups of 6 tens would be 300, plus 5 groups of 1, which are going to be 5. So now I've figured out the products of both 5 times 60 and 5 times 1, but to find the product of 5 times 61, I need to combine those numbers again for my total answer of 305. With your partner, talk about, did you get that same answer, or did you go wrong in one of your parts? And then what kind of error did you make? Was it a computation error? Did you not know what 5 times 6 was? Did you forget to add the 0 at the end because you're talking about groups of 10? Did you add wrong? Or was it a problem decomposing the number? Whatever mistake you made, that's fine. We're just starting. This is our first day doing this, but make sure now on the next problem you pay attention so you don't make that same mistake again. Okay, here's our next problem. On your whiteboards, write down our problem. 5 groups of 36, or 5 times 36. Now, I can't do that mentally in my head very easily, but because the distributive property tells me that I can break apart numbers and multiply each one by the same factor, then I can think about how would I want to break 36 apart, so this would be an easier problem to do. Go ahead and write it down on your whiteboard, then teachers pause and have students share what they did. If you're at home, just write down your answer on your paper and then follow along with each step. Okay, so I would break down 36 into 30 and 6. I could break it down any way I wanted. To me, I like those numbers that end in a 0, and I know my basic fact. So if I break it into those two parts, it's going to be easiest for me to multiply. So now I'm going to do my 5 times 30, okay? And then I'm going to multiply, and I'm going to distribute my 5 times 6. How I would write that out would look like this. So 5 times 30, distributing it, plus my 5 times 6. So now we're going to calculate 5 groups of 30. Well, I'm going to start out and think about, well, what's 5 groups of 3? 5, 10, 15, but it's not 15. It's 3 tens, so it would be 150. Now my 5 times 6, I know that is my basic fact of 30. So now I have 150 plus 30 because I broke my 36 into two parts, but now I have to combine them back to get my total answer. So 150 plus 30 would be 50, 60, 70, 80. 180 would be my total product of 5 times 36. So again, look at where did you go wrong? Or maybe you got it right this time. If you did make a mistake, double check. Where did you go wrong? Did you not decompose it accurately? Did you make a math error with your multiplication? Did you add your numbers incorrectly? Whatever your mistake was, make sure that you pay attention to that on the next example that you do together. So today we added in a new property. We talked about the distributive property. Remember, with a distributive property, a multiplier can be distributed across the equation without affecting the product. Those were the examples we just did. We could break apart 4 plus 2, we could multiply the 3 times each of those. Or, again, if it was a multi-digit number, we could break it into 20 and 4, multiply it out, and then add them back together. Okay, so that was distributive. Just like I'm handing out that 3, I'm multiplying that 3 by everything inside the parentheses, handing out the papers to each person. We also have talked about the associative property. Remember, numbers can be grouped differently. So that grouped is the important part of that one. Remember, our numbers are staying in the same order with this property. We're just simply changing the grouping or the parentheses. We've also talked about the commutative property. That one is talking about the order of the numbers. So the order of the numbers can flip-flop or change. 3 plus 4 is the same as 4 plus 3. 3 times 4 is the same as 4 times 3. We also talked about the identity property of addition. Remember, identity, you stay the same. When you add 0 to anything in addition, the identity property says it's going to stay that same value. We also talked about the identity property in multiplication. Any number can keep its identity by multiplying it by 1. And finally, our zero property. Any number multiplied by 0 is always 0. So if you keep these properties in mind when we're solving problems this year, it'll make it a lot easier to solve some of the problems mentally, or for you to break them down in ways that become numbers that you like to work with and make it easier to come up with the answers. Okay, so we're going to do a quick review before we move on to our activity. So let's look at this problem. 4 times 20 is equivalent to 20 times 4. Which property is it? Write it down on your paper of these choices. Again, there's two parts. We don't need to know the name, what's happening to the numbers, but we also have to look carefully at the operators. Well, I can see my numbers are changing order, and I'm multiplying, so I can get rid of all my addition properties. Changing order is not distributive, it's not associative, it is commutative. I commute back and forth to work. Okay, let's look at this property. I start out with 5 times two numbers that I'm adding inside parentheses, and then I get, oh, it looks like to me I'm taking the 5 and I'm distributing it to each part. So which property would this one be? Write it down. Because I'm sharing that 5, I'm breaking it apart and sharing it. It's the property we were working on today, the distributive property of multiplication. Because remember, we only can do distributive property when we're talking about multiplication. Okay, look at this problem. Which property does this one show? Here are our choices. Write it down on your paper or on your whiteboard. What's staying the same and what's changing? Well, in this one, our numbers are staying in the same order. What is changing is our grouping symbols. We're grouping the 2 and the 5 first, and then the 5 and the 19. So when we change the grouping symbols, we are talking about the associative property, but because we're multiplying, it has to be this one, the associative property of multiplication. Remember, our associates, 2 and 5 could go together first, or we could do 5 and 19. In this problem, I would choose this way to look at it, because 2 and 5 is 10. 10 times 19 would be 190, and that's way easier than trying to multiply 5 by 19 and then multiply it by 2. So that's why we would actually use this property, to make that same problem easier to solve. Okay, so which property is this? Again, we always want to make sure we look, what's staying the same? What do I see is staying the same on either side of my equal sign or my equation? I see I have a 5, and then I have a 32 here, and I have it made it a 30 and a 2 here. So which property would that be if I'm breaking apart the number? Look at your choices and write them down. Well, I am distributing. First of all, I decomposed my 32 into 30 plus 2, and then I'm distributing that 5 times each one. So now I could make this a mental math problem. 5 times 30, I would say would be 150. Then 5 times 2 is 10. 150 plus 10 is 160. So that would be a fast way to solve that problem. Okay, so we're going to go back to our learning target. I can identify and apply the commutative, associative, and distributive properties. So I want you to rate yourself now. Again, maybe you're feeling good with the identifying the commutative and associative, but maybe the distributive is still a little tricky, and that's okay. So maybe you're thinking you're at a 3 or a 4. We're going to do some more practices with an activity next. So rate yourself from 1 to 5. Show your teacher where you are. And if you're not at a 4 or a 5, then think about, what things do I need to do when we're doing our activity? What mistakes did I make in my practice that I don't want to make again when we're doing our activity or game? If you're at home learner, go ahead and look at what your assignment in Google is posted.